So we set these things up. These are the normal kind of crazy things. These are underlying degree distributions. I'm not thinking about the fact that they're bipartite. This is just, we could think of the degree distributions for stories, tropes. And we have the number of other friends distribution R as well. So these are things we've done before. We have all these things, the normalization, right? So the probability, total probability is 1. That's what evaluating a generating function at 1 gives you. And the derivatives are averages of whatever the quantity is. And so the average number of tropes that a story contains, and the average number of stories a trope is in. The first derivative is the generating function evaluated at 1. I know, words, it's great. Okay. I wanted all those to change. Did they not change because I reloaded it? Yeah, all right. Sorry. All right, I'll fix it up. These should be all these bipartite ones. Generating functions, yes. All right, we'll get through it. So this is our old story is a beautiful thing for generating functions. If we have a variable, again, we roll some weird die, it gives us some number, 7. Then we go to another one and we roll that one 7 times and add them all up. Right, so we've got U, V, we get our new thing W. Then it's a composition of the generating functions to give the new generating function. So that's something we use over and over with these random networks, because we hit a node, it has so many other friends, and we want to know how many friends they have total. I got to this example and showed you that you can get some pretty interesting things out of these, just this random stuff. So this is for movies. This is the number of co-stars that a movie star will have, or an actor will have. It should be, I guess, co-actors. And it has a weird distribution, right? And it's really that what's happened is there are these peaks around 15 and 15. 15, 30, 45. But I guess really 14. Yeah, it has to start at 14. So if you're in one movie, then you have, on average, 14 other friends, right? Because on average, there are 15 people in a movie. And so there's some mixture of people who have 1 movie, 2 movies, 3 movies, and you can see there's a little bit of a lump there as well, but it's smoothing out. Yeah. So maybe after a while you could see something like this and think, if this is from a network, you could see that there's some community structure in this, right? Yeah. And you might think, oh, well, a good test for that would be, is there some underlying maybe we're only looking at people and we need to add places, right? We need to add some sort of context that they're mixing in. Maybe we can do that. Okay. All right, so to see if this thing is connected, then this is, again, just that tree. We're going to we'd start with some probability that a trope has so many stories, and then we have to go through these 2 steps, right? So this will be, this is just a little piece here, which is going to be the probability that if we hit a story that it has so many other tropes involved, right? And this is just the underlying degree distribution stuff. And then we have to do it again, but we're going to switch now. We're going to say we're going to hit a trope, and how many other stories does it have? Yep. And so these things should be right. Yeah. Yeah. So here's the complicating piece, right? So we're interested in how many other stories, if we go here and we hit this story, how many other, am I looking at the right thing? Yes, how many other stories does it eventually lead to, right? So this one, if we hit this one, we're going to have all of these guys over here, right? That's really how many this one leads to of its own type. So it's going to be a mixture of how many friends it has. That's going to be this distribution here. And then we're composing it with how many other friends the trope distribution has, and that's in here. So it's actually simpler than what, I mean, it's along the lines of what we did before, but it's a simple construction. And then we're going to have the flip of this here, right? So this is how many, so we're walking along here, this is how many stories a trope is in, how many other stories a trope is in, and then how many other tropes are in stories. So again, you know, this we're rolling this die, and then we're summing up this one. All right, okay. So that's what this madness is. You know, I thought I changed that. No, okay. This is really just from the previous slide, but the generating function for the induced one, which we'll call this bipartite thing, it's going to be, well, we're going to randomly sample a node in the story space. It has some degree, and then we randomly sample from the trope distributions, other friends distribution, sum up that, and that will give us how many, right, if we start here, how many other stories do we get to as we go up and down once. That's what that is. So, and we'll need to know how this works if we follow along one link in this bipartite thing and come down and go up again. How many do we tend to reach? Or what's the actual distribution for that? Yeah. So it's a composition of these easier generating functions for just the underlying degree distribution. All right, same thing for the other side. Don't have to worry about it. It's a flip.